Hello and welcome to this video. Today, we will be talking about measures of central tendency. The definition of measures of central tendency is any single value that is used to pinpoint the center of the data, or the typical value is a measure of central tendency. It is frequently called the average, and the mean, median, mode, and mid-range are the four different ways to measure the central tendency. Let's start off with the mean. The mean, or the arithmetic mean, is the most common average. It is the sum of all values occurrences divided by the number of values in the set. The mean of a sample is represented by the symbol known as x bar, also known as x bar, and the mean of a population is represented by the symbol mu. Lastly, the sample mean is used to estimate the population mean. Let's move on to the properties of mean. The sum of all the deviations of all the measurements in a set from the mean is 0. It can be calculated from any set of numerical data, so it always exists. A set of numerical data has one and only one mean. It lends itself to a higher statistical treatment. It is the most reliable since it takes into account every item in the set of data. It is also greatly affected by an outlier or extreme or deviant value. It is used only if the data in interval or ratio and when normally distributed. Moving on to the rounding rule for the mean, one additional decimal place should be added to the mean than what is found in the raw data. For instance, the mean should be adjusted to the nearest tenth if the raw data are presented as full numbers, and the mean should be rounded to the nearest hundredth if the data are given in tenths, and so on. And a quick short disclaimer, always remember consistency is the best way to have a great meaning in your life. Enough of that. Moving on to mean for ungrouped data, the sample mean with the formula x bar equals summation of x over n, where x bar is the sample mean, x is the value of any particular observations or measurements, and summation x is the sum of all the values of x, and n is the total number of values in the sample. And the population mean, and again with the formula mu equals summation of x over n, where mu is the population mean and x is the value of any particular observations or measurement. Summation x is the sum of all values of x, and n is the total number of values in the population. Now, this is the last category of mean, which is the weighted mean, applicable to options of different weights, useful when various classes or groups contribute differently to the total. It is found by multiplying each value by its corresponding weight and dividing by the sum of the weights. As you can see here, the formula, wait, it's not loading, Wm bar equals to the summation of frequency of x all over the summation of the frequency of each weight. Also, where f is the frequency of each weight and x is the corresponding weights.
Good day everyone, I am Roger Armahinay and I will be the next presenter of the day. So I am going to present to you the concept of median, which is a measure of central tendency. So we have here the definition of median. The median is the middle value of a set of numbers, and the median is the same as the 50th percentile of the set of numbers. In other words, the median is the middle of a set of numbers with half of the values less than the median and half of the values greater than the median. In order for us to have a better understanding with the concept of median, let's have an example. Take the set of numbers 8, 6, 11, 5, 9, 23, and 4. To find the median, we first sort the numbers from lowest to highest or in ascending order. The sorted numbers are 4, 5, 6, 8, 9, 11, and 23. The median is then the middle number, and because there are 7 numbers in the set, the fourth number, which is 8, is our median. So what does one do when there is an even numbers in a set? Then, the median is the average of the two middle numbers. So we have here the second example of set of numbers to show this principle. The second set of numbers is 7, 3, 10, 2, 9, 2, 1, and 4. Then, in order the set of numbers and get 1, 2, 2, 3, 4, 7, 9, and 10. The second set of numbers has 8 numbers. With the two middle numbers, which are the numbers 3 and 4, the median would be then the average of those two numbers, which is 3.5.
Good day everyone, I'm here to continue Mr. Mainay's topic, which is all about median. And for you to better understand it, let me share to you a few more examples. Here we have a set of numbers which consist of 2, 30, 15, 21, 8, 9, and 8. First, we have to arrange the data in ascending or descending order. And since the data is odd, the median is the middle rank, which is 9. Pretty simple, right? But what if the data is even? The same thing, we have to arrange the data in ascending order. And since it is even, the median is the average of the two middle rank values or the middle point. And for this data set, the median is 22. Rules. There are only 2 rules to find the median of ungrouped data. First, if n is odd, the median is the middle rank. And the second one, if n is even, the median is the average of the two middle rank values or the middle point. That's for the median. Next up is all about mode. So please allow me to introduce you to Miss Vina Panes for an understanding of mode.
Good day everyone, I am Vinamay E. Panes and I'm going to discuss the mode. The mode is the measure of central tendency that identifies the category or score that occurs the most frequently within the distribution of data. In other words, it is the most common score or the score that appears the highest number of times in a distribution. There are different types of mode. The first is said to be unimodal, which means there's only one mode in a given data set. Example, identify the mode in a given data set. 6, 7, 2, 3, 4, 6, 2, and 6. The first thing you need to do is to make a table. It is shown in a screen, the table. So the mode here is 6 since it has the highest number of frequency. This type of mode is called unimodal. The second type of mode is called bimodal, which means the data has 2 modes. Example, identify the mode in a given data set. 2, 9, 5, 7, 8, 6, 4, 7, and 5. So, just like the other one, the first thing you need to do is to make a table. The table will make it easier for you to identify the mode. So, The mode in this given dataset is 5 and 7. This mode is called bimodal since it has two modes. The next type of mode is called multimodal. This is when a dataset has more than two values that occur within the greatest frequency and each value is used as the mode. Example: identify the mode in a given dataset: 1, 8, 4, 2, 1, 9, 8, and 5. So, make a table, then it will be easy for you to identify the mode. The mode in this given dataset is 1, 8, and 9. Since this has three modes, it is called multimodal. There's also some cases when the dataset have the same number of frequencies. When this occurs, the dataset is called to be no mode. Example: identify the mode in a given dataset: 1, 2, 3, 4, 5, and 6. This dataset has no modes since all the data have the same number of frequencies. Here are some example problems. Number 1. An ice cream parlor owner was tracking the number of strawberry cones he had sold over a week. His results were 72, 82, 89, 92, 91, 82, and 79. Determine the mode of the cone sold. So, the first thing you need to do is to make a table. It is shown in the table that the mode is 82 and it is bimodal. Number 2. Alexa was doing a survey. She asked her girl classmates how many siblings they had and recorded the results. The results were 4, 2, 5, 3, 2, 3, 1, and 6. The mode in this problem is 2, 3, and 1 since it has the highest number of frequency. And this dataset is called multimodal.
Next is we are gonna talk about mid-range. So the mid-range is a rough estimate of the middle. It is found by adding the lowest and highest values in the dataset and dividing by 2. It is a very rough estimate of the average and can be affected by one extremely high or low value. The symbol MR is used for the mid-range. So when we are talking about mid-range, we are simply talking about the midpoint of the given dataset. And MR can be found by adding the lowest and highest value and dividing by 2. Properties of mid-range. The mid-range is easy to compute. The mid-range gives the midpoint. The mid-range is unique. Mid-range is affected by the extreme small or large values. Mid-range can be applied for interval and ratio data. So example number 1. A high school teacher at a small private school assigns trigonometry practice problems to be worked via the net. Students must use a password to access the problems, and the time of login and logoff are automatically recorded for the teacher. At the end of the week, the teacher examines the amount of time each student spent working the assigned problems. The data is provided below in minutes. Find the mid-range. So we are given the data set, which is 15, 28, 25, 48, 22, 43, 49, 34, 22, 33, 27, 25, 22, 20, and 39. To find the mid-range, we are going to find out the lowest and highest values first. So the lowest value in the given dataset is 15, and the highest value is 49. So to find the mid-range, we are simply gonna add 15 plus 49 and divide it by 2. So 15 plus 49 is equal to 64 divided by 2 is equal to 32. Therefore, the mid-range of the given dataset is 32. So example number 2. Midterm exam scores for a small advanced neuroanatomy class are provided below. Scores represent percent of items marked correct on the exam. Find the mid-range. So we are given the data 87, 99, 75, 87, 94, 75, 35, 88, 87, and 93. And the lowest and highest values in the given data set is 35 and 99 respectively. So to find out the mid-range, we are only gonna add again the lowest and highest values and divide it by 2. So 35 plus 99 divided by 2 is equal to 134 divided by 2 equals to 67. Therefore, the mid-range of the given data is 67. So for the last example, a group committed to quality television has been concerned about a new talk show. For 2 weeks, they decided to count the number of words that must be bleeped as to obscene for the television and the number of physical altercations. They hope that after recording this data, that they will be able to argue that the show is inappropriate for television, particularly during the day. The day of number of words censored is provided below. Find the mid-range. So we are given the data 342, 267, 321, 157, 33, 349, 254, 166, 132, and 289. So the lowest value in the data is 33 and the highest value is 349. So therefore, to find out the mid-range of the given data, we are gonna add the 33 and 349 divided by 2 is equal to 382 divided by 2, and the answer is 191. So therefore, the mid-range of the given data set is 191.